So prime means main meridian. So what is the main thing? We will see into it. But as it is a great circle, so it is dividing Earth into two equal parts. So this side is called as Eastern Hemisphere, right? But this side is called as Hemisphere. Alright, dear. Now in Eastern and Western Hemisphere, we have drawn certain other circles or lines, like from here, this way. Imagine from the backward side of it. Similarly, other ones like this way, from backward side, circle, this way, this way. Like this one is making, suppose 1 degree, so we will call it 1 degree east. E indicate Eastern Hemisphere. If it is 2 degree, we indicate it 2 degree west, sorry, east. So on, like say this line is 10 degree, 10 degree east, 11 degree east, 12 degree east, so on. Isn't it? Same way, you can make the other circles or lines this way, this way. Continue. So like 80 degree east, 90 degree east, so on. What would be the last one? Imagine this is Earth. So if you draw a one line here, like say this is the line, this is Greenwich line. It is dividing Earth into two equal parts. Let me hold reverse. Greenwich line. So if you draw some circle here like this way, so with respect to this plane, Greenwich plane, it is making 1 degree angle, 2 degree, 3 degree. You getting? So what would be this angle? This one? What is this angle? A line which is here, exactly here. Don't you think this is now 90 degree angle? So 90 from here to here, this is 90. So 1, 2, 3, 4, so on, 45, 46, 47, 90. 90 lines can be drawn into this part. Similarly, 91, 120, 130, 90 further in this part. Because from here to this entire backward side, half circle is done. So it is overall 180 lines we can draw toward this side. Got it? So 1, 2, 3, 4, 90. Similarly, 91, 92, so on, and 120. So last would be definitely 180 degree east. So towards the one side of this Greenwich line, one hemisphere, Eastern Hemisphere, 180 lines can be drawn. Same thing toward the west, like this way. 1 degree west, 2 degree west, 3 degree west. So we will call it like 10 degree W. W means west. So on. So we can draw these lines or circles. 90. Then what would be the last one? 180 degree west. These circles. These circles are called as longitudes or Greenwich line. No, longitudes or meridian. Prime meridian is Greenwich, which is making a 0 degree angle. Right? Here is center. C for center. So question is, what are the properties of these longitudes and what are the uses of them? So first see properties of longitudes. See what are the properties of them. Number one. Then number, total number. Tell me the number. Latitudes were 181, 19 north, 19 south, 0 degree, equator also. But how many are these? 180 towards one hemisphere, 180 towards other. So it is 360. So you can ask questions, sir, why not 361? What about 0? Actually 0 is same as that of 180 in the backward side. So either calculate 0 or 180. But 90 degree north, 90 degree south, 0 degree equator, latitude, these are three different things. So we have to add only one, either 0 degree or 180 degree, not both. So total number of longitudes is 360, not 361. But total number of latitudes with a difference of 1 degree is 91. Equator is included. Isn't it? So that is the total number. Are they parallel to each other? No. Latitudes are parallel to each other. They are not. Like if you draw the latitudes here, this is equator. And see, these are latitude lines. So they are parallel to each other. See, they are parallel to each other. See, these are latitudes. These are parallel to each other. But are these yellow lines longitudes are also parallel. No, 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 no. They are intersecting. So they are not parallel. So you can say they intersect. They means all of them intersect at where? Poles. So at poles they will get united. So if you see the top from them, upper part, this is the appearance. Like this is the poles. So all longitudes come and get united here like this way. This way. So a network is formed. So they get united at the poles. They are not parallel. They intersect. Third thing. Okay. Are they equidistant from each other? Like two. These focus on two. Let me make it this one red line. So this is one longitude. See, this is the next one. So is the distance between two nearby longitude is uniform? No, not uniform. It is more distance here, less here, further less here. As you move toward the pole, distance between them goes on decreasing, and finally it becomes zero at the poles. So they are not uniformly separated. But latitudes, these are uniformly separated. What is the distance between two latitude? 111 kilometer. Right? So they are equidistant, parallel as well. But these are not parallel, not equidistant. They are not equidistant. Equidistant नहीं है. Fourth thing, two nearby longitudes has more distance near equator and distance between them. So two nearby longitudes has more distance near equator and distance between them decreases towards poles. So as we move toward the poles, the distance between them gradually decreases. All right, but latitudes are equidistant from each other. Did you get it? Okay. Now issue is how many latitudes are great circle? Only one, equator. This middle one, equator. It is dividing the earth into two equal parts, northern hemisphere, southern hemisphere. This longitude 0 degree, it is also dividing the earth into two equal parts, east and west. But think rationally. Put pressure on your mind and then think. What about other longitudes? Are not they great circle? They are. How? Like consider this is earth. Same thing, this is wire. I have this thing in my proximity, wire. So if you draw this circle this way, definitely it is dividing earth into two equal parts. But if you take this circle like this way, is not again it is dividing earth into two equal parts? Yes. This side, this side. If you take this circle, a little bit tilted, again it is dividing earth into two equal parts, this side, this side. So all longitudes are capable to divide earth into two equal parts. Take it imaginary one, like my hand is separating this part, grip, and this part. So these are the two hemispheres. So if you imagine a line here that separate earth into two equal parts. If you make a line like this way, this direction. So this circle, which is towards me, and this one, which is towards your side, this one. So again two hemisphere. If you make circle here, so grip it like this way, this way. Like imagine rationally you have a onion. So cut the onion vertically anyhow into two equal parts. Yes or no? Yes, you can cut it. Like you can cut it this way, this way, this way, this way, any way. You can cut it into two equal parts. So all longitudes are great circle. But only equator is a great circle. Other latitudes are not great circle. Look at it. All longitudes are great circle. So is there is a logic to say one is a prime? Prime means main longitude. Answer is no. You can make any longitude as a great circle. Like where am I standing on the earth? Let make a one circle from my place, and I would say that it is now dividing the earth into east and west hemisphere. You can do that. Like one line is passing through Delhi, one longitude is passing through Delhi. Take that as a prime meridian, and toward the left hand side of it, say that is eastern hemisphere, right hand side of it, say western hemisphere. Right? So that will become 0 degree now. So with respect to that cutting from Delhi, that plane from Delhi starts measuring other longitudes. You can do that. Similarly, some longitude passing through, say, Kolkata. A longitude is passing through Kolkata. Take that as a prime longitude or prime meridian. Left hand side of it, say that is eastern hemisphere. Western side of it, say that is western hemisphere. So with respect to the plane of that Kolkata longitude, measure other longitudes. 1 degree east, 2 degree east. Did you get it? What I'm saying? 10 degree west, 50 degree west, 90 degree west. You can do this thing. So there is no logic to say that it is prime, but conventionally it is considered as prime, 0 degree, Greenwich line. Why so? There is a colonial legacy behind it. Actually, we have to take one longitude to divide Earth into East and West hemisphere. So during the colonial time period, Britishers, they used to rule our whole Earth, from India, Australia, Indonesia to the America, isn't it? So Rani Victoria or Queen Victoria is overseeing the administration of whole world. So what she do? She used to divide the earth into two equal parts just below her chair. The line is passing below her chair. She called right hand side of her is the western hemisphere, left hand side of her is the eastern hemisphere. So that is the logic. Otherwise, there is no technicality behind it, isn't it? So still this convention is followed. This is eastern hemisphere, this is western hemisphere. Isn't it, dear? So all longitudes are great circle. We can write the fifth point. All longitudes are great circle. But equator is the only latitude which is the great circle. Done? One more thing. Tell me, are the circumference or this length of latitude is same? Like what I am asking, the 0 degree. Is the length of 0 degree over Earth and the length of this one, this latitude of Earth, is it same? Say it is 60 degree north. So 60 degree north circumference and 0 degree north circumference, is it same? No, 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 no. Consider football. So if you make a line in the middle of football, horizontal line in the middle of football, it is like an equator. It is more lengthier because it is bulgy in the middle part. But if you make a one circle at upper part of football, that circle will be small because the bulge of the earth is less. So equator is the longest latitude. Other are not equal to the equator. As you go away, the distance, the size of these length of these latitude goes on decreasing. But what do you think about longitude? The yellow lines are not, they are of same length. Like this is Earth. If you draw circle here, 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 anywhere, they are of same length. True. So let's write the sixth point. All longitudes are of, but latitudes are not same length, are of same length. Equator is the largest latitude and North Pole is the smallest one, dot only. Okay? So that is basic understanding of latitudes and longitude. Now question is, why we have drawn so much lines over Earth? Why we take so much pain to draw these lines? Man do everything for convenience. So we are looking for some sort of convenience. That's why we have drawn these lines. Otherwise, why we should take so much pain? These are not practical lines, imaginary lines. So they have some uses. See, what is the use of these latitude lines? Latitudes are used to locate a place. Okay. So move to the next one. Use of, first see here, use of latitudes. What is the use? So they are used to locate a place on globe. They are also used to find north south distance between two places. this thing. Why? Because they are parallel to each other, equidistant from each other. So dear, if you know the latitudinal position of some place, like let me give you the latitudinal position of India. So this part of India, northern and southern part of India, see, Gujarat part, there lies southern part. So this is northern part of India. So the latitudinal position of this southern point of India on mainland, 8 degree 4 minute north. Similarly, longitudes are also divided into minutes, 60 minutes. So 8 degree 4 minute north. But the longitudinal position of this northernmost part of India is 37 degree 17 minute north. Or round of the figure, take it 8, take it 17. So it is say take 737, it is only 8. Can you calculate the north and south extent of India? Yes. How much latitudes pass between them? You can calculate 38, 37 minus 8. What is this value? Subtract 8 from 37. 7, 8, 29. Is it 29? So between two latitudes, there is a distance of 111. So multiply 29 by 111. It will give you the answer. 3,214 kilometer, north to south extent. So definitely we can find out the north-south distance between two places if we know the latitudinal position. Like what is the difference between Bhubaneswar, Kolkata, Chennai, Delhi, vertical distance, north-south distance we can calculate. So this is the meaning of this thing. Second is they are used to locate a place on globe. Like if you know the particular latitude and longitude of a place, you can exactly tell where that place is. Like if I give you south of India is 8 degree 4 minute north. So you can know it is in the, by looking at the N, you can say it is in the northern hemisphere. So it is the southernmost part of India which is in N. It is the northernmost part of India which is also in N. Both are N, means south, north, both corner are in N. It means India is in northern hemisphere. This is the meaning. So you can exactly locate a place if you know latitude and longitude. Like Google Map. If you do Google, if you book your, Ola, Uber or anything on the Google, so latitude, longitude is confirmed. So by latitudes, you can know where it is in northern, southern. And by longitude, you can exactly find out the location of a place. So that is the use of latitudes. I hope you have understand it. There is no rocket science in it, but there are some hidden conceptual things. Every time in IAS prelims, two questions or three questions, or sometime one is asked from this basic part of geography. Like this year also, two questions are there. You will see what are these questions. So that is use of latitudes. Okay, now come to the next one. Use of longitudes. See what is the use. So it is interesting thing. It is used for time calculation. Calculate the time. That is use of longitude. Okay. So if someone asks you what is time, how you will define it? Batao? How you can define time? Time simply does mean passage of time, passage of event. Like I am here. So at a particular time I am in front of you. I changes my position. So that event has passed. Early in the morning, sun was rising. So sunrise. So that was the event rise of sun. But at 12 o'clock, sun is somewhere there into the sky. At 5 or 6, sun is setting. So events are changing. Right? So time is simply a passing of the event. So if certain event pass, then it is called as time. Did you get it? See, what does it mean? Event can be anything, like my body is event. I'm in front of you. So as I'm in front of you, if you set your clock, like as sir started the classes or class, sir, as sir come in front of us, let's fix the clock as 9. So that is 9. So let's fix your clock as 9 a.m. Right? Tomorrow when sir will come again. So by that way we will set our clock. So event can be anything, but is it sure that tomorrow I will come in front of you? Or you take some event which is in your surrounding, like you consider some cow. If this cow will come, I will consider that as a time event. So if cow will pass, so time is passing. So you can consider that as well as a event. But what is the problem in these things? It is not surety that the cow will repeat again and again the same position in front of you. So those events are considered which are repetitive and universal, which you know are sure to occur. So if you consider those things as a reference thing, then with respect to them, you consider the other events. And what is that? That is sun. So sun is one such event that is universal. It will repeat its position again and again, again, again. So it is a best thing for the reference purpose. So let's take sun position in the sky as a reference point. So consider yourself when sun will be exactly here overhead over me, I will call it as 12 a.m. or 12 p.m. or 9 a.m., 10 a.m. So with respect to changing position of sun, I will calculate the time. So this event is sun, passing of sun. So simply speaking, time is calculated as a passing of sun with respect to the earth. So passing of sun's position with respect to earth is called as time. What time है? I have a question. Is sun is actually changing its position in the universe? Answer is no. This is earth. This is earth. Sun is fixed towards one side of earth. Sun is, although sun is also changing its position in the universe or in galaxy, but with respect to earth, it is by and large fixed frame. So sun is not changing its position. Like you see, early morning sun is there, then in afternoon sun comes there, in evening sun is there. So sun is actually not changing position. Sun seems to be changing its position. Reality is who is changing its position? Earth is rotating. So this rotation of earth is making a difference. Right? Like consider this finger, my finger, as a one point, and yourself, camera, yourself means that is camera is fixed position, that is sun. So one thing, how with respect to finger, the position of camera can change. Camera itself starts moving this way. If it is moving, then I will from finger will see the position of camera is changing like this. It is changing, right? Second thing is camera is fixed, means you are fixed, but this bottle is rotating. So as it is rotating, so with respect to this finger position is changing, like this way. So at this point, finger is exactly in front of you, exactly in front of you. But as it further tilt, there is a certain angle. Further tilt, certain angle. Further tilt. Now finger is looking in that side, but you are in this side. So what is angle? 90-degree angle. So finger is looking you at the 90-degree angle this way. So my face is toward this side, but my neck is toward this side. So 90-degree angle. But you are looking. You are viewable from me. But as soon as this finger further tilt, now as I tilt like this way, so there is no way that I can see this camera because my vision is in this side only. Same thing happens over here. It's like your finger is in Delhi. So from Delhi, as finger is here, from Delhi you can see the camera or that object, right? So this is a reference view of the Delhi. So if you are facing here, this part you can see. So as you tilt it like this way, now you can see this part. So earlier that vision is not visible now. You further tilt it, you can see this part. Like if you tilt there, you can see this part. But as soon as you tilt further, now I cannot see this one. Same is the reason that sun sometimes appears into the sky at different angles. Sometimes sun became overhead of you, vertical, and sometimes sun is not visible because you are in the opposite side. So why sun is changing its position? The answer is rotation of earth. So earth is rotating. We will come to this rotation in detail, but earth rotation is responsible for the appearance of the sun position change. Did you get it? So if earth make a one complete rotation, like I am here, if I make this complete rotation like this way, how much angle I have done in this complete rotation? 360 degree. Yes. So in one rotation, like I am looking camera, in this 360 degree angle, I will again come in front of camera. So if that is sun, so by 360 degree angle, again sun position is same. So that is event. Same event is repeated. Is not so? This is the event. I'm looking at the sun from earth. But if I make a 360 degree angle, again the event is repeated. So that is universal. Sun will again come if you make a 360 degree angle. That's why for time calculation, sun position is considered. Okay, dear. So see now, earth make uh, uh, how much angle in one day? 360 degree angle. So we can say for 360 degree angle, how much time earth take? 24 hours are taken. Yes or no? One day is taken. Earth make one complete rotation in one day. So you can write it reverse as well. Right? In 24 hours, how much angle? 360 degree angle is covered. Can you calculate in 1 hour how much angle earth makes? Yes. 1 hour. Simple mathematics is equal to 360 by 24. So by this way, you can calculate, by this way, you can calculate in 1 hour how much tilt earth can make, how much angle earth can make. So you, if you solve it, 3 से 6 से करें, 6 4 जा 24, 6 0. Solve it, 15 into 4, 15 degree. So in 1 hour, earth rotate by 15 degree. This is the result. In 1 hour, like if I am looking at you, in 1 hour, I will tilt by 15 degree. In further 1 hour, further 15 degree. In further 1 hour, further 15 degree, so on. So in 24 hours, 360 degree will be done. Right? What is the meaning of 1 hour? 1 hour means 60 minutes. So in 60 minutes, how much angle is covered? 15 degree angle is covered. So can you calculate in, can you write it reverse? 15 degree in 60 minutes? Can you calculate 1 degree in how much minute? Yes, 1 degree. Does mean 60 by 15. If you solve it, 15 into 4, 4 minute. Right? So that is the final conclusion. Means for 1 degree tilt, earth requires 4 minutes. 1 degree means one longitude is passed because there are 360 lines. Right? So these longitudes are drawn in such a way, two longitudes are 4 minutes away from each other. We can make this conclusion. This conclusion can be drawn. Two nearby longitudes are separated by 4 minutes. This is the meaning. Like 0 degree is facing the sun, 1 degree is waiting. After 4 minutes, it will tilt there, and now 1 degree is in front of you. After further 4 minutes, it will further take and 2 degree come in front of you. After further 4 minutes, 3 degree come in front of you. That is the meaning of this tilt. Right? So that is use of longitude. We use it for calculation of time. So if someone has given you the longitudinal position of a particular place, can you calculate the time with respect to other longitudes? Yes, you can calculate. How? We will further understand it. But to understand this concept in detail, there is a need to go into the background of time in detail. All right. So, concept of time. Come to the concept of time. So, there are 3 types of time in our geography. One is called as local time. Second is called as standard time. Third is called as international time. Three type of time: local, standard, international. So first understand local time. So it is a time of a particular longitude or place with respect to the position of sun. Time of a particular place. Place means, or you can say longitude, because every place is on certain longitude. So time of a particular place or longitude with respect to position of sun in sky, that is called as local time. Alright, dear? With respect to position of sun in sky. Okay, see, what does it mean? Like, say this is surface of earth. I am standing at some place. So for me, sun shift its position into the sky. So I will check the angle of this surface, me and the sun. So that angle will tell me the time. How? See, this is surface of earth. In geography diagram, surface is represented by this symbol. So here comes sun. So it is sunrise, say. So sun will travel into the sky by this way. This is journey of sun. So if I am looking there, like this bottle, consider this finger as a point or place, because this finger is on certain longitude. So that is a point. There is sun. That is sun. So if finger is on opposite side, sun means east side. That is east side. Your side is east side. What is this one? Blackboard is in the west side. Opposite. East to west. So if I face the eastern side, what is the right hand side? The direction is south. Left hand side is north. Right? Directions are clear. We are considering that as east. So this became west. This became north. This became south. So I have a question. Where is this finger? It is in which side? Which direction? West side. So can it see the sun? No. There is sun. Because finger can see, but there is no sun there. So it is night for this finger. Finger tilt further. Can it see the sun now? No, no, no. But when finger comes here in this southern direction, can finger see the sun? Yes, now it can see. Because from this side, eastern side to the northern and northern to the western, this entire part is visible from the finger. So for this finger, there is sun. So what is the angle between sun, the finger and this surface? Don't you know? Don't you think if you make a single line, the finger, sun and this line, surface is in a same line, same plane. So that is 0-degree angle. So it is for this finger that sun is rising. But if finger slightly, sun shift with respect to this finger. Right? So this is a sunrise. If this place is here, say this place is a, so surface and this are on the same line, so that is 0-degree angle. It is dear called as sunrise. But as this finger tilt further, so it does mean that sun slightly shift upward. So sun for this finger comes at this position, suppose. Now you can calculate the angle. This angle, place, and this surface. Suppose this angle come 30-degree. So by checking this angle, you can calculate time now. Consider this sunrise. You can make it any time. Like say it is a 12 o'clock for my watch. कुछ भी आप कह सकते हैं. कुछ भी, anything you say it. But let's suppose you have considered 6 a.m. as a sunrise and set your clock at 6 a.m. Right? Your mechanical clock make a one complete circle in 24 hours. So you have set your clock at 6 a.m. and for them, isn't it? So once the earth will rotate, the sun will shift upward into the sky for this finger. or this point A. When sun come here, it is 30-degree angle. Can you tell me what is the time when sun will come here? You can tell. Because this angle is actually due to rotation of Earth. So 30-degree change means Earth is rotated by 30-degree. So Earth rotates 50-degree in 1 hour, 30-degree in 2 hour. So add the 2 hour. So it is 8 a.m. now for this place. So you are calculating the time just looking at the sun into the sky. This is local time. So every place on the Earth can do this thing. Okay. Further, if sun shifted to this angle place, further rise up, you have calculated this angle and this angle comes as time. What is the time? Further add 2 hour. Further add 2 hour, 30, 60 means 30-degree extra. So it is 10 a.m. So see, your clock is telling you the time now just by looking at the position of sun. So you can do it practically. Next day, tomorrow, or now only, go outside and locate the sun into sky. Make angle between plane, yourself and sun, and then tell the time. Is here, exactly here. So what is this angle between sun rays and this place? Vertical. So 90-degree angle. It means sun is overhead. Sun rises from there, moves into the sky, and now it is overhead. So half of the journey the sun is completed in the sky. This half journey is left. Isn't it? So it is 6 a.m., 10 a.m. Did you get it? 6 a.m., 10 a.m. and then it is say whatever 6, 8, 10, 12. So कितना हो जाएगा जब आएगा 10 में 2 further add कर दो, so it is 12. We call it as noon. Half of the day is covered. Sun has to cover this remaining half journey. By same way, calculate this angle. If this angle is 120, you can tell me the time. 120 means 30 extra degree. So 2 further minute you can add, 2 further hours you can add. So it is 2 p.m. By this way, you can calculate these angles and tell the position of sun. When it is there, so it is 180. So it is sunset. So this is journey of sun. So just by looking at the angle between you, surface and sun, if you are calculating time, that is called as local time. Did you get it? So like this is Earth. This is particular longitude. So all points which are situated on same longitude, like A point, B point, C point, D point, all will have same longitude, same time, same local time. So we can draw one conclusion from here. All places situated on same longitude has same local time, right? Same local time. Like this bottle. So this point, this point, this point, all which are on the same, they are making same angle with this camera. So if the finger comes here, so this finger is in now front of camera, vertical ho gaya, plane, and this one 90-degree angle. So not only for this point, but all these points which are in front of you, this camera now. Okay. So all places situated on the same longitude have a same local time. This is concept of time. Okay? That is a concept of local time. But come to standard time, what does it mean? If each and everyone starts setting the clock or considering the time as per the local time, then Delhi habitats has a different time. People living in Kolkata has different time. In Guwahati different time. Gandhinagar different time. Because they are situated on different longitudes. Do you get it? Suppose Government of India says that 9 a.m. is a office time for Ministry of Defense or for Railway Ministry, say. Right? So 9 a.m. what? 9 a.m. is local time. So Delhi person come out and see, oh no, it is 8 a.m. So it is only 30-degree angle with sun, so it is 8 only. But someone who is in, say, Allahabad or Lucknow, that person come out and see, oh, it is 9 a.m. It is actually 45 degrees, so 45 means 9 a.m. So let's go to office. Who is in Gandhinagar, that person has calculated that the angle with sun presently is say 10 degree only. So it is 7 a.m., 6, 8 a.m. for me. So I will go after 2 hour, 3 hour. So if each and every person starts doing time calculation with respect to their position, then n number of time will come into existence. So how to follow the government directions? It will create a time confusion for habitants of a one country. So from here comes the concept of a standard time, right? So let's see that what is standard time. For that, first see the extension of India. So there is, you see, Gujarat part. Here is Meghalaya, Tripura, Mizoram, Nagaland, and this is Arunachal. So this western corner of India, this one, is roughly at 68 degree few minutes. So say it is 68. This one is 97 degree 25 minute. So 68 degree 7 minute east. 97 degree 25 minute east. So 7 subtract from here, right? Somewhat subtract from here. So let's round off the figure, make it 67 degree. Make it 97 degree. So overall, there is a difference of 30 degree, na? 30 degree longitude, 67, 77, 87, 97. So overall, there is a 30 degree longitude difference. Two longitudes are 4 minutes away. So what is the difference between this line and this line, local time difference? You can calculate. It will come 120 minutes. 120 minutes means 2 hours. It means this Arunachal Pradesh is 2 hours ahead in time as compared to Gujarat, Rajasthan part. Each longitude has a difference of the time. So we cannot run the administration of country by the local time. So there is need to consider a one time for whole country. From here comes the concept of the standard time. Did you get it? So what is standard time? A time with respect to a reference longitude decided by the government. Go back, see what is standard time. So let me rub it. Standard time. Time of a whole country with respect to a reference longitude decided by country, decided by government, is called as standard time. Right? So it is basically drawn to remove the time confusion. That is the standard time. So it depends upon the government, will of the government. So Indian government has decided that a line is to be drawn. Like here is a one line, a one longitude that is nearby in the middle part of country. It is having a longitude of 82 degree 30 minute east. I mean, between 82 and 83, that one. So government has considered that as a reference line. So whatever is the local time at this place, as this line, with respect to sun position, So sun ka, what is the position of sun with respect to this line? That is considered as time of whole country. Why not this line is made over here? Because now at this time, the difference of Arunachal Pradesh Northeast state will come more. But from this line 82 and 97, you can see the difference. Nikal, you can calculate the difference. 82, 97, how far they are? 15 degree. So 15 into 4, 15 into 4, 60, still it is 1 over difference. 15 into 4, 1 over difference. But the places which are nearby, they are few minute difference. Right? So this line is called as Indian Standard Timeline, IST. Indian Standard Timeline. So entire country time is considered with respect to this line. So you can call someone into Delhi, someone into Kolkata, someone in Guwahati, Chennai, all of time will say my clock is showing the same time. So it is inbuilt. Any company, any watchmaking company has to operate in India. By default, they will set the same time. Understand? So whole country has a one time now. This is called a standard timeline concept or standard time. But what about those countries whose east-west extension is very much? Like see the map of Russia. Russia is much east-west extended, very much. So if they make a one line, still there is a difference of 9-10 hours in their eastern part and this. So just by making a one line, still the confusion cannot be drawn, isn't it? It is a day towards one side of Russia and a night in the other side of Russia. So their problems cannot be solved even by a single line. So they have a concept of time zone. What is that? If one line is drawn and in this zone, the time will be with respect to this line. The next line here, now in this next zone, the time is with respect to this line. So on, this is next line. So in the further next zone, time is with respect to this. So big east-west extended countries like Russia has multiple zones. They have a concept of time zones. They have 11 time zones. It keeps on changing. Depends upon government. America has time zones. But small countries like Sri Lanka, there is no need of time zone in them. Pakistan, no need of time zone in them. India has a one timeline. Still, there is a confusion of time in eastern part and this timeline, 1 hour ahead. So when government says at 6 a.m. the office will end, it is 6 a.m. actually for Greenwich, this land, India standard timeline. So sun is setting for this one, 6 p.m. Sun is setting for this one, but it is already night for them. That's why it is not related with their biological clock. Biological clock means sunrise, sunset. So it is already night. So if their female, that is a hilly area also, if their female go back to their house in night, that creates a problem. That's why they are demanding that give us a separate time zone. But critics argue that if we start giving a time zone for different region, it will promote regionalism, separatism. So government is not agreeing with that their demand or not accepting their demand. But British was smart. British used to do that thing. Before independence, India was guided by two timelines. So there were two time zones. One is the line passing through Guwahati here. So entire eastern part of India, northeast India, Assam, Odisha, Bihar, middle half UP, right? Jharkhand, Chhattisgarh, Sikkim, these were Bangladesh, all entire Bangladesh also. That was colony of Britain, was guided by this timeline. They called it as a tea estate timeline, Chai Bagan, TESTATE, because Assam is famous for tea estate timeline. Okay. Earlier it passes through Darjeeling, because Darjeeling was also their capital city, summer capital, but then they shifted to Guwahati. Second line which passes through Shimla. Shimla was also their summer capital. So the rest of the country was guided by the Shimla timeline. All right, dear. But after independence, government of India has decided remove this time confusion because at that time integration was at most required. That was the priority. So government make 82° 30' east, which is passing through Allahabad as a Indian standard timeline, and entire country's time is now calculated with respect to this timeline. Do you get it? That is a concept of standard timeline, standard time. Now international time. So it is a time of country with respect to Greenwich line. This is called as international time. So local time of London, because Greenwich is passing through London, is considered, and then the time of other longitudes or other countries' time is decided. Right? So actually local time of London is the international time of London. Local time of Allahabad is a standard time of Allahabad. Isn't it? See, what does it mean? For that, consider Earth. So say this is the world map. So on the world map, let's see where is the Greenwich line. So that is, say, equator. This is Africa, this way. So here are your Scandinavian countries: India, Malaysia, Japanese Island, Indonesia, Kalimantan, Papua New Guinea, Australia, Tasmania, New Zealand, Madagascar, Sri Lanka, Antarctica, South America, North America, this one, Greenland, here lies London. So this is the, say, Greenwich line. It passes through countries of, it passes through Spain also, if you make a correct map, passes through countries of Africa also. This is Greenwich line, 0 degree. So let's say there is a 12 o'clock, midday. So sun is overhead in London. Midday means sun is overhead in London. Overhead, half of the day for sun, London is crossed. So what is international time in India? So Indian standard longitude is passing from here, this way, it is passing. 82 degree, 30 minute east. So we have to calculate time of India now with respect to this line. So what is the difference between 0 and 82? 82 difference, okay. So calculate the difference, 82 into 4, 4 into 2, 8, 8 into 4, 32. So 328 minute is the difference. But we have 82 and a half. So 83 hota to 4 hota. So add 2 more minutes. So 328 minute plus 2 more minutes. This is the difference between India time and the London time. So it is come 330 minute. So for calculating it into hour, divided by 60, you can calculate. 6, 5 is 30.3065 is 30. 5.5. It means 5 hour 30 minute. So India is 5 hours 30 minute. What I should say? Ahead of London or behind the London? Ahead of London, because this is eastern side. So eastern hemisphere is first come in front of sun, because earth is rotating from west to east. This is the west, this is east. So this longitude will first come in front of sun. So midday is already passed from this line. So it is ahead in time. So eastern hemisphere is ahead in time, western is behind the time. Did you get it? So add 5 hour 30 minute in 0, and it is a 24-hour clock. So time up, you can say like this way, in India is a 5:30 p.m., but it is 24-hour clock. So after 12, 13, 14, 15, 16, 17:30. So time, international time in India is 17:30 now. This way you can calculate the time of any part of the world. This is a concept of international time. Okay, dear? Any part of the world you can calculate by this way. So if you visit some airport, there are clocks. One is which one shows standard time of that country. Second shows international time. Even some European countries show the local time also. But in India, visit any international airport, two clocks are placed. One shows the time of India, second shows international time. Is it done? So earlier the Greenwich line was also used for date calculation before. So towards this side it is one date, towards this side it is other date. Like what is the date today? क्या तारीख है आज? 15th January. So it is 15th January toward this side, but 14th January toward this side, as per earlier criteria. Same line for time, same line for date, but it creates a problem in these countries which are situated eastward, like Spain, like Portugal, right? Like Netherlands, Belgium, African countries, even in London also, right? Even in England also. Moreover, there is 14 January in America, 15 January in India or Asia. So it was also colony of Britain. It was also colony of Britain. So if Rani Victoria has to decide declare a holiday on a particular day. 15th January is holiday. So Indians are celebrating holiday, but Americans are in the country, are at their job, right? So to reduce this time confusion, what was decided? A treaty was done in 1882. It is famously called as Bering Strait Treaty. All colonial powers of world, European colonial powers of world, unite in London and then decide to remove this date confusion. What is Bering? Bering is the name of sea. That sea is here, this one. And what is strait? Strait is a narrow water channel which separate two land masses. Let me write. Strait, narrow water channel which separates two land masses. Like between India and Sri Lanka, this is called as Park Strait. This is called as Malacca Strait. These are straits. Strait of Gibraltar, this one, right? This is Aden, Babal Mandeb, Strait of Babal Mandeb, connecting Aden with the Red Sea, right? These are straits. Hormuz Strait, this is Hormuz Strait, Persian Gulf ka rasta. So if you look the map, world map, geography, in the geography classes you should have a map simultaneously. Atlas hona chahiye. So if you see this part and this part of world here, so this part come very close to this part here. So that is the Russia, this is Alaska of America. That is Bering Sea. So this is a strait called as Bering Strait. This one is called as Bering Strait, which separate Russia from America. It was decided that if we draw a line here, then this line will give convenience. What is that convenience? Entire landmass come into one side, and behind this globe there is a Pacific Ocean. So water and landmass is separated. So this was the scheme that was done in this Bering Strait Treaty. So a line was made. That line is called as IDL, International Date Line. So this line is drawn in such a way it separates land masses from the water masses, right? It passes through there. But some islands like Hawaii Islands, they come here. This is Hawaii Island group. There are many islands here, Micronesia, Melanesia, Polynesia. So this line became little bit zigzag. It put these islands toward this side, then it goes there, there, like this way, it separate, and then again became straight. So it put land masses, islands also even toward this side, and water is toward this side. So it is little bit zigzag, not perfectly straight line. So it is international date line, and longitude here is 180 degree. East west is same thing, you know. So at 180 degree longitude, it is decided to have a international date line. Is it in there? So that is a concept of time and date. Okay. Some interesting questions are asked, like see, if one airplane leave from Tokyo, at 9 a.m. as per this longitude, it reaches there in New York in 2 hours only. In 2 hours only. But longitude of Tokyo and this is given. Suppose Tokyo is at 170 degree west. This one, New York, is at say 160 degree west. That is east. 170 degree east, that is 160 degree west. Ship only take 2 hours. So at 9 a.m. in this clock, a passenger is sitting here at 9 a.m. He set the clock as 9 a.m. At 11 a.m. the ship flight reaches there. Question is, what should be the time over there? You can calculate. So what is difference between 160 west and 160 east? So it is 160 west to 160 east, 180. 180 plus 10 more. Okay, कितना होगा 160 west and 160 east. So 160 from 0, तो 160 तो इधर हो गए, 170 there, so 160 plus 160 plus 10 more, okay कि नहीं? So you can calculate 160 plus 170, 0, 330. So it is overall 330. So multiplied by 4, 0, 4 into 3, 12, 1, 12, 13. 13, 20 minutes divided by 60, 0. 6 2s are 12, right? 1, 2, 6 2s are 12, 22 hours. तो subtract करें या add कर दें? Subtract करें. Because this part is ahead. Japan is called as land of rising sun because it will first face the sun. So subtract 22 hours. 22 hours subtract कर दो. कर लो. 24 करोगे तो 9 AM हो जाएगा प्रीवियस डे का, तो 2 ऐड कर दीजिए. सो इट इज नाउ 11 AM ऑफ प्रीवियस डे. बाय दिस वे यू कैन कैलकुलेट टाइम एंड डेट. Is that it? If certain ship crosses from west to east in this international line, the navigators they add 1 day ahead. If crossed from east to west, they subtract 1 day. Isn't it? Okay, some other questions like here is a city of Perth, here is a Durban. A ship is moving from Perth to Durban, right? A question. A ship is moving from Perth to Durban. Perth से Durban जा रही है. Perth city in Australia, Durban is there. From it is ship is moving from Perth to Durban from east to west direction. ऐसे जा रही है. हो तो ऐसे भी सकता है, सर्कम नेविगेट करके ऐसे, नो नो, ईस्ट टू वेस्ट डायरेक्टली जा रही है ऐसे, दिस वे, with same speed as that of the rotation of earth, with same speed as that of rotation of earth. तो अर्थ के रोटेशन से ही चल रही है इतने स्पीड से. ओके, फुल स्टॉप. when ship leave the Perth, when ship leave the Perth, sun was overhead in the sky. कोई शिप चल रही है, ship is moving from Perth to Durban from east to west, and when ship leave the Perth, sun was overhead in the sky, right? Full stop. What is the position of sun with respect to passengers of this ship? What is the position of sun in the sky for the passengers of this ship? लिखो ऑप्शन, राइट डाउन. ऑप्शन ए, sun is overhead. लिखो sun is overhead. Second, sun passes towards west usually. Sun passes towards west usually, means with the same space. Next, sun shift towards east side usually. Next, sun shift towards west with double rate. Sun shift towards west with double rate. So first thing is sun is fixed, means overhead ही रहेगा. Sun is moving towards eastern side with same speed as it usually do. Sun is shifting west usually do. Sun is shifting west but with double rate. So you should think about this question. Similarly, reverse the situation. In the second question, reverse the situation. Ship is moving from Durban to Perth with same speed as that of rotation of Earth, right? And reverse the situation, options are same. Okay, so this is about the imaginary lines of our Earth. See, what is the reality now? Earth is tilted, you know. This is tilted Earth. North Pole, South Pole. So let's make it tilted Earth. This is tilted Earth. So Here lies the axis. So this is north pole, this is south pole. On this tilted earth, the latitudes and longitudes are there. So this line, actually it get much tilted. This way, tilt it slightly. Like this is north pole, this is south pole. Make the axis passing through center. So these lines are our latitudinal lines. So you can see this is equator, very center. So these are latitudes. So just to make it one line only, equator. So these are latitudes. In southern hemisphere also, parallel lines. But these are longitudes. So is Greenwich line coincide with the axis? Yes. These are lines. So there is a grid of latitudes and longitudes over Earth, or tilted Earth, you can say. This way. Grid of latitudes and longitudes over tilted Earth. This way. And Earth is rotating from west to east. There lies big sun. This is the reality over Earth. Latitudes and longitudes. Okay, dear. Now, in the basic geography, one more topic we have to discuss: motions of Earth. Motions of Earth. Then in geomorphology part of optional paper, we will discuss universe formation, Earth formation theories. But before that, we are doing basics in our geography. Is it done? Is it done? You can make latitude, longitudes as well. Say this is equator, 23.5 degree north. Sorry, this one, 66.5 degree north. This one, 23.5 degree south. This one, 66.5 degree south. So Tropic of Cancer, Capricorn, Arctic Circle, Antarctic Circle. Right? We will come back to this figure again. But now shift to the next topic. Motions of Earth. What Earth is doing in this solar system. Motions of Earth. Motions of Earth. So Earth actually has a 5 motions. 2 motions are of solar system and of galaxy. Actually, our solar system itself is moving with the along the center of galaxy. That is called as galactic year. So it take more than 70 million years to make one complete revolution. Solar system revolve around center of galaxy. So Earth is moving with sun. That is one motion. Moreover, our galaxy itself is moving. Right? So that is second motion, motion with sun, motion with galaxy. But here we are concerned with motion, motion in the solar system. So Earth is doing 3 sort of motions. One is called as rotation. Second is called as revolution. Third is called as precision. This is E. This is also E. Precision, precision. Three type of motions, and they has their impact. Okay, first come to rotation. So see what is rotation. Number one, I'm writing some point or directly write the definition. It is circulatory motion of earth on its on axis. This is rotation, right? Circulatory motion on its axis is rotation. Circulatory, a circle is made like this way, okay, but on its own axis. So this is earth, this is axis of earth. So earth rotates this way, motioning this way on its own axis is rotation, right? So let's make that figure here as well. This is tilted earth, small figure. This is center, this is axis. So this tilted motion, equator, this way. This one, this is motion called as rotation. Always make small diagrams. So make it your habit to draw the small and neat and clean diagrams, right? Because in ultimately in the examination you have to make the small diagram. Space is limited. So this motion is called as rotation. So we have certain questions over here. First, why earth rotate? Why rotation? Second, how rotation? How earth rotate? Third, time taken in this rotation. Fourth, effect of rotation. Okay. So first question is, why earth rotate? Why earth rotate? So you will not found the correct answer it why, but there is a reason. The forces which are responsible for rotation is definitely gravitational pull, moon, these things, pull of sun, moon, they rotate that. But reality is, with these forces earth is rotating because earth want to become a perfect sphere. Earth is not perfect sphere yet. Somewhere it is up, down, right? So earth is not a perfect sphere like this is the shape of earth, up, down. It wants to become a perfect sphere, and it can become perfect sphere only by rotation. Anything can become perfect sphere by rotation. So why earth wants to become perfect sphere? Because sphere, your spherical shape is one which has minimum surface area. Like why water droplet is spherical, air bubble is spherical, sun is spherical, moon, earth, heavenly bodies, mostly they are spherical in shape. Why? Because spherical shape is the most stable shape, and it is a law of nature. Everyone wants stability, economic stability, social stability, ecological stability, similarly structural stability as well. So answer of this one, why earth rotate? So answer is to achieve stability. Achieve stability by making spherical shape. So day it became perfect spherical, its speed may stop, rotation may stop. There are examples, some they rotate very slowly. It is true. So that is the reason, but real answer is no one knows why it is rotating. It is just a one presumption. But what is science? Science is a good presumption. एक अच्छा अनुमान ही विज्ञान है. Okay, question is how Earth rotate? How? So generally it is said that Earth rotates east. That is true as well. Earth rotates from west to east. Because that is our understanding, but it is a partial right answer. Like that direction is east. I told you east. So this direction is west. This is south. This is north, right? So look at this finger. Finger is facing in east side, like there, your side. So how Earth rotate? East to west. So this finger should go this way or this way. East to west means this way. So as finger is rotating, it now faces the north. Yes. Further rotate by this way. It is now in the west side. Yes. Now what happened further? It will go there. To make complete rotation, it should go there. Now it is in south. There again in east. But let me reverse the situation here. It is facing now which side? Western. Now it is moving from west to the east. Yes or no? Reverse the situation. East to west, this way. But for half of it rotation, it is moving from west to east. Yes or no? Consider myself, I am towards east. So I am moving from east to west. So west is my backside. So this way I am moving east to west. But for half of journey, east, yes or no? Yes. So how you can so convincingly say that Earth is moving from east to west? Actually, it is not a perfect answer. It is fifth standard answer, layman answer. It is a technical answer. Although that is correct, because finally, as I am moving there, this way also I will finally come toward the eastern side. Is that it? So east means sun. I will face the sun by this rotation. So that's why we are calling west to east. But what is real answer? Real answer is this is Earth. As it is moving this way, so look this Earth from top. Look it from top. So it is rotating this way, this way. So put your clock here. So your clock is moving this way, but Earth is moving this way. So anti-clockwise. But look it from bottom, moving this way. Now turn your hand and look at your clock. Now look at your clock. Watch. That is also rotating this way. So you can say clockwise from the south, but anti-clockwise from the north. So that should be the answer. How Earth rotate? Clockwise from south pole. You can do it. Take some. You can do it practically. Take watch and then analyze the situation. You will understand. But anti-clockwise from north pole. See, opposite movement. So Earth seems to be facing a opposite movement from north and south pole. That's why some effect of rotation Coriolis force will have an opposite impact in north and southern hemisphere. We will come to that, right? So this is how Earth rotate. Now come to the time. How much time Earth take to rotate? Generally it is 24 hours. That is true. Means one day. But question is it exactly 24 hours? No. It is slightly more than or less than? Slightly less than. So what is the real time? 23 hours. Right? 56 minutes. 4 seconds. That is the SEC second. Exact time. So almost 4 ही हो गया है. 24 ही हो गया है. 4 minutes is less. Less than 4 minutes is left. Then it is 24. But this is the real time taken by Earth to rotate. Is it done? But important thing is what are the effect of rotation. So for that we have to shift to next page. Effect of rotation. See, number one, first effect. Formation of day and night, Formation of day and night. First effect. Okay, see. Suppose this is earth, suppose it is straight, there is sun. So this part of earth which is facing the sun, like take my body, you are sun. So this half part of my body is facing the sun, so that is day for this front side. But for my rear backward side, it is night. Someone is there, it is night, right? After some time I rotate, but day for this backward side of me. Same thing happens over earth. So this is earth. So this finger, it is in day. It is in day. That is east. It is in day. But this backward side, this pan is in the night. After it rotate, so it is margin of day and night. It goes there, now it is in night. So this is how days and night are formed. So can we make even imaginary line which separate day from night? Yes, we can. So in 2 dimension, in 3 dimension, we can show the entire sphere, but in 2 dimension, we have to manage with the circle only. So this part of earth is in front of sun. So here is the day. You can consider 3 dimensional way. So half this, half that side. This circle is like this way, right? So this is day. But what about this back side? This is in night. So we can make an imaginary line which separate day from night. This line is called as, or this circle you can say, is called as circle of illumination. So circle of illumination separate day from night. Day और night को अलग करता है. Circle of illumination. Alright, dear. It is situation when earth is straight on its axis. But like this bottle, if you put this bottle straight, how circle of illumination? It will pass from there. Like let me make a imaginary way. This is wire. Let's mix this. Like you camera is the sun. So this way, this circle. So day night. So exactly passing through North Pole and South Pole. It is a great circle, yes. Circle of illumination is great circle. It is dividing earth into two equal parts. But if the bottle is straight, but what is the reality? Bottle is tilted. Earth is tilted. Earth is not straight, it is tilted. So how circle of illumination moves now? This way. Not passing through north and south pole. Dekho. Not passing through top and bottom. But still it is a great circle. It is dividing earth into two equal parts. This and this. But not passing through north and south if it is tilted. So let's make the figure of tilted earth. Like this is the perfect diagram, tilted earth. Okay, so let's make a circle of illumination. So take green line. Sun rays, they are coming. They are coming. So sun rays, they are even reaching to this point. So this part, like this way, you can make circle of illumination. As this way. So this is circle of illumination. But sunlight is maximally reaching to this point, not here. So there is night in this part. Night at South Pole, day at North Pole in this particular situation. But if ये straight होती, so the axis coincide. इसको सीधा करो, axis coincide with circle of illumination. Had it been straight, but it is not reality. Reality is earth is tilted. So this part is in day. This part is in day. This part is in night now. दिख रहा है? तो ये है डे में, ये है नाइट में. So it is not necessarily that day and night are equal due to tiltation of how. Look at particular latitude. Like see this one yellow line. Don't you think this more yellow line, like make it 3 dimension? Dot means like इसको देखो ये वाले ऐसे dotted line means from backward side this way. So say this is the longitude. Dotted means from back side. So don't you think some place if you put it on here, किसी place को यहाँ put कर दे, A place को. A is in day. When earth will rotate, this A will come there. A is in day. A is in day. A is in day. From backward side also in the day. So for this long journey, A will remain into the day, and for this short journey only, A is into the night. Yes. So for 8 days are longer, night are shorter. Reverse, see here in southern side. What about this longitude? Take some line, ye wala, Tropic of Capricorn. Make dotted line, that is from the backward side. So for this big journey, it is in night, but small journey it is in day. So here nights are longer, days are shorter. Here days are longer, night are shorter. In this particular situation, we will properly understand it in revolution. So it is a tiltation which definitely affect the duration of day and night. अगर ये सीधी होती यार, बिल्कुल सीधी होती तो क्या होता? You can think yourself. Make straight earth. Makes a straight earth like this way. Like this way. Here is center. So make latitudes. Equator. Dotted line is from backward side. So see, this is equator. See, this is center of earth. Dotted line, this is equator. And dotted means from backward side of earth. I said, make it Tropic of Cancer. Dotted means from backward side. Arctic Circle, this way. Tropic of Capricorn. Antarctic Circle, this way. Make the axis of earth. This is axis of earth. North Pole, South Pole. Now, if in this situation, sun rays come from this side, this side, this side, sun rays. So we can perfectly imagine or believe that this half part of earth is in day. This one. This half part of earth is in day. Either day ho jata. And this half part of earth is in night. So still it is a great circle. It is still dividing earth into two equal parts. Still it is a great circle. But in this situation, don't you think, consider any longitude, like latitude, sorry, this one, Tropic of Cancer. Don't you think now half part of it is in day, similarly half part is in night. Equator, half part of it is in day, half part of it is in night. Capricorn, if you make a clear diagram, half part of it is in day, half is in night. All latitudes will be halfly divided. So, had when Earth is straight, days duration became equal to night duration. That is 12 over day, 12 over night. तो कुछ ऐसा हो जाता. Okay, but due to tiltation, there is a difference of the duration of day and night. तो difference हो गया है. Okay, dear. Did you get it? Okay, now come to back. ये हो गया होगा? I think so. This figure is done. Now come back. Here. Effect of rotation. So first is the formation of day and night. Okay. So let me rub it. See what is the second effect. Second main effect is Coriolis force. Formation. It is also prelims question of UPSC this year. जो क्वेश्चन आते हैं, you can check the 2024 question paper. They have given a two statement for Coriolis force. Now see what is this Coriolis force? It come into existence due to rotation of Earth. As Earth is rotating, so it operates over Earth. Right? So before coming to Coriolis force, you should tell me what is force. What is force? In physics, we define force. First law of motion. Second law of motion, sorry. Force is mass into acceleration. That is force. But how in a layman term we define force, and it is definition of definition physics as well. Like I am pushing this blackboard or this wall like this way. So I am applying a force. That is force. Okay. This pan, it is placed here. I pull it. This is force. Right. So force is something which really changes the position of, like it is in rest. I create a motion which really moves the object. or it is moving, I stop it. So which really changes the position of object? Second, which tries to change. Like I'm pushing it, but it is not moving, but I'm trying my level best, right? So force is something which really changes the position of the object, or which tries to change the position of object. Okay, dear. So force, we put it into two categories. Physics consider force as a force, but for other sciences like meteorological sciences, orbital mechanics, force we put it into two parts. One is called as real force. Second is called as pseudo force. Two type of forces. So real force is one which actually moves object from rest. Means they can actually create the motion in the object. So if pan is stationary, I move it, it is a real force, right? But what is pseudo force? Which can't move object from rest. Rest means stationary. So if some object is stationary, like pan is stationary, but there is some force which is not able to move it. That is pseudo force. It can move, like my hand can move. So what is this force? This is called as mechanical force due to potential energy, kinetic energy. So energy stored in my body, due to that energy I move it. So there are examples of real force. See how many examples? Three examples. Like what is the position of this pen? Is it in rest? I leave it. It's not it moves. It moves. I leave it. Moves. So there is a force which moves it from rest. What is that force? Gravity. Downward force. So one of the example is gravity is a real force. Second, I push it, mechanical force due to kinetic potential energy. Third, if you turn on the fan, air starts moving. Why? Because of pressure difference. Wind move because of pressure difference. So we called it PGF, pressure gradient force. Pressure gradient means difference. So if there is a difference of pressure, high, low pressure, air will move, water will move. So it operates on fluidic substance. But mechanical gravity, they can operate on any substance, fluidic, solid, liquid, gas, everyone. But this is on which can flow. Okay? Pseudo force, they can't move the object from rest, but they operates on moving object. Right? So you can say they can't move object from rest, they operates on moving object only. So if some object is moving, then they can operate. Like examples. क्या क्या examples है? Number one, see, friction force. Actually, physics consider it as a force, but not in the other sciences. Like the span is stationary. Is friction force is over it? Answer is no. Friction force is zero. But as soon as I start moving it, there is a friction which comes into existence between pan and my hand. It operates opposite. It tries to slow down the speed. But if object is rest, friction force is not operating. Right? Then second one, CP, centripetal, and CF, centrifugal. They operate on rotating object. So unless and until object will rotate, like this pan is rotating this way. So one force is inward, it is CP, one force is CF. So unless and until they will not come into motion, especially in rotationary motion, it will not come into existence. So ये है pseudo force. Third is this Coriolis force. Coriolis also example. Is also example of this force. It is due to the rotation of earth. जब अर्थ रोटेट करती है तो कोरियलिस फोर्स लगती है. Because as you know, this pan, the bottle, let's place this you know, whatever it is, tap on it, lid on it, rotate this bottle. So देखो, it falls down because it comes under the impact of this rotating thing. So that force is pseudo force. So unless and until this bottle was not rotating, the lid was fixed on it. But as I start moving, the lid fall down. Why? Because a force applied on it. So that is Coriolis force. So there are certain rules of Coriolis force. So there is need to understand it in detail. Rules of Coriolis force. See, Number one, first thing, it operates only on a moving object. Means Coriolis force is zero on stationary object. Like I am stationary now, so no Coriolis force on me. Why zero? Because now I am rotating with the rotation of Earth. Are you stationary? If you are sitting, no. For objects or on the Earth, you are stationary. But if someone is observing you from Moon, you are moving. You are rotating with the rotation of Earth. So I am stationary. So only force that is applicable on me is rotation of Earth. But I starts moving. So I am moving on the moving Earth. It is a relative motion now. बात समझ रहे? जैसे ऐसे समझो, ये कोई ट्रेन है. This is some train. In this train you are placed. Train is moving with 60 kilometer per hour. So what is the speed of this person? A 60. But this person starts running with 10 kilometer per hour. Now can you tell me what is the speed of this person? It is called as relative speed concept. So if it is moving in same direction, you have to subtract. ऐसे तो होता है 60 minus 10, its speed will come 50. But if it is moving in opposite direction, its speed will add up 60 plus 10. Mathematics में question solve करते हैं. Two trains are approaching. What is relative speed? Two trains are moving in same direction. What is relative speed? So if you move on the moving earth, then relative motion come into existence. That is Coriolis. So it is operates only on moving objects, zero on the stationary objects. Second thing, it is zero at equator. Actually, this force is required for formation of cyclones, rotation. So if it is zero, then cyclones cannot form over equator. It is zero at equator. But maximum at poles. Now, why it is zero? So for that, you have to understand this same analogy again. This is train A. It is moving in this direction with say 60 kilometer per hour. Inside it, some person is sitting. Right? This person is moving in opposite direction, here to here, with say 40 kilometer per hour. What is relative speed? Opposite, 60 plus 40, 100. So relative speed is 100 kilometer per hour. So train speed, relative speed. Say this is Earth, this is this person relative speed. But suppose this is a second situation. This is train B. This train B is moving in this direction with say 2000 kilometer per hour, very speed. It is super fast train. And a person in it is moving in opposite with say same 40 kilometer per hour. What is relative speed? Same thing, 2000 plus 40, 2040 kilometer per hour. Is 2040 and 2000 are very different numbers? No, they are very close to each other. So 2040 bolo ya 2000 bol do, better that is thing. Like if you have scored 67 point say 7% marks in your 10th examination, what did you say to others? How much marks I scored? 99% says I scored 68% marks. Why so? Why you make it 68? Because 0.3 is negligible. So you remove that and say it is 68. Understand? This is called as round off figure. Same thing is here. So 2040 is almost equal to the 2000. 40 is nothing in front of 2000. But can you say 100 is same as that of 60? Now it is no. Because 100 is almost double of 60. 120 के पास चला गया है. Very close to 120. So you cannot take a round of figure over here. But here you can take a round of figure. So what does it mean? If this person is moving at 40 kilometer per hour speed in 2000 kilometer per hour train, person is still moving with 2000 kilometer per hour. The movement of person to the outside person, if someone is observing this person, that person motion is not observable at all. So for outsiders, it looks like that person is still moving with the speed of train. Same thing happens over Earth. This is Earth. Is the speed of rotation of Earth is same everywhere? No. Over equator, Earth rotate fastly. Fast rotation. Over poles here, slow rotation. Now you are thinking it why? Actually, it is a distance because this point has to cover this big distance in same 24 hours. This point has to cover this small distance in same 24 hours. So you can calculate speed is equal to distance upon time. Time is same for this place A and B. But distance, A cover more distance in 24 hours. Big distance. So speed should be more. So Earth rotates fastly over equator, slowly over poles. So Earth speed is so fast that if someone is running on the equator, that relative speed is negligible, almost in a motion with that of the Earth. That's why we take Coriolis force 0 at equator. But as you move away, Coriolis force goes on increasing and became maximum over the poles. And it is required for cyclones. So in study in climatology, cyclones can never form over equator. ठीक है भाई? So that is second rule. Okay, third rule. It speed of moving object. It can't change speed of moving object. Right? Speed नहीं बदल सकती. What it can do? It can deflect only moving object. So, but it can deflect moving object. Means it can change the direction. Like if this person is moving in this direction with 60 kilometer per hour, so Coriolis force can at most, like instead of moving straight, can deflect it with, but does not change the speed. Still it will move 60 kilometer per hour. So it is only a deflecting force, not increasing, decreasing. Friction can decrease the speed, but it can only deflect. Right? Okay. So how it deflect, that is a question now. अच्छा, एक और पॉइंट लिखे पहले, फोर्थ, faster the speed, more is deflection. Deflection ज्यादा होगा. So you can say Coriolis force, or you can say speed of object, is directly proportional to Coriolis force. This is the meaning. So if object is moving with 60 kilometer, this much is deflection. But imagine object is moving with 150 kilometer per hour, or say take a realistic figure 100 kilometer per hour. So deflection will be more. See, here is only this much deflection, but here is more deflection. This is what it means to say, because now more relative motion come into existence. Okay. Next, fifth. See, that is important point. Right now, in northern hemisphere, fifth point here. In northern hemisphere, it deflect moving object towards its right side. This is important. So northern hemisphere में right side में deflection, but in southern hemisphere deflection is towards left side. Towards left side. Left side की तरफ होगा. Okay, what does it mean? Say this is Earth, this is equator. So if object is moving this way, then it will be deflected towards its right. This is the right side of it. But in south, if object is moving this way, it will deflect left. This is the left of it. So reverse deflection है, opposite. Why it is so? Because of counter rotation of Earth. अभी तो पढ़ा ना, anti clockwise in north hemisphere, clockwise in south hemisphere. So there is a counter impact. It operates on all moving object. It can be wind, it can be river, it can be water, it can be airplane, it can be vehicles, and anything. Even you start running for long distance. Like if I want to move from here to there, but this room shift this side, so instead of going straight, I will go there. Did you notice that? As hoga, I will go there. If room shift this side, if floor shift this side, same thing happens over earth, only deflection. Okay, dear? So that is for rotation, first one. So it is 5. ठीक है? So this is for today. आज बस इतना ही करते हैं. I have some urgent work. बाकी remaining thing we will do in next lecture. So revolution, say from revolution onward. So rotation is done from revolution onward. We will discuss tomorrow in next lecture. It also leads to the formation of seasons. Okay, then precision. तो आज बस यही बंद करते हैं. हाँ हाँ, आंसर ऑफ द प्रीवियस क्वेश्चंस. क्या क्वेश्चन कहाँ से निकालते हैं इसमें? आई डोंट नो, इसके ऊपर तो आ नहीं रहे हैं. कैसे क्वेश्चन पता चलता है? क्या क्वेश्चन? जो मैंने दिया वो क्वेश्चन, उसका तो आप बताओ. व्हाई शुड आई टेल? एयरप्लेन? नो नो नो, यू शुड टेल. वो एयरप्लेन शिप की बात हो रही है. वो आप बताओ, पहले सोचो 1-2 दिन, ऐसे नहीं एक दिन में. पता नहीं कहाँ से इसमें वो आता चैट. चलो जो भी, व्हाटएवर. सो दिस इज फॉर टुडे. रिमेनिंग थिंग वी विल डू इट इन नेक्स्ट लेक्चर.